Welcome to the Deep Dive. We're here to cut through the noise and get to what really matters. And today, wow, we are plunging into something huge. How artificial intelligence is, well, radically reshaping the tech industry. This isn't about small changes. We're talking a fundamental re-engineering, really, of how tech gets built, how it gets delivered. Our mission today: to pull out the key insights from a piece called AI, the New Engineering Imperative. It gives us this fantastic ground-level view from a machine learning software engineer at Google, a guy named Varshney. So as we get into this, I want you to keep a core question in mind. What does it really mean to be an engineer in this AI-first world? And maybe even more important, just how fast is all this happening? We're aiming to uncover the maybe surprising speed and depth of how AI is getting woven into everything, straight from someone who's actually, living it.
Exactly. And that's why this deep dive feels so necessary right now. What we're looking at, it's not just like adding a few new tools to the toolbox. It's a profound shift, a real recalibration of what's expected from tech professionals, the skills needed, the whole landscape of innovation itself. It's changing. Understanding this isn't just, interesting if you're in tech. It's vital for anyone tracking where technology is going. And frankly, how to stay relevant in this ecosystem that's evolving so quickly.
Okay. This sounds, yeah, profound is the right word. So who exactly is shedding light on this for us? We're really lucky to be drawing on the direct experiences of Varshney. He's a machine learning software engineer right there at Google. So this isn't just theory, right? It's coming from someone actually building this future we're talking about. He's based in the Bay Area, has a pretty impressive background, electrical engineering from BITS Pilani, a master's in computer science from Carnegie Mellon. And his career before Google, I mean, he worked at Flipkart, AWS, Splunk. He joined Google about 2 years ago. So he's seen a lot, a seasoned veteran who's watched big tech evolve.
Right. And that experience is key. What's really fascinating is how Varshney describes big tech today. He says the industry has become far more dynamic and results-driven compared to when he started. And this isn't just a minor tweak. It's a whole reorientation, like you said, of priorities, of pace.
Right.
Think about traditional software development. Often, long planning phases, these multi-week sprints, sometimes a bit rigid, almost waterfall-like. But now, Varshney really hammers home that the focus is just relentlessly on agility and rapid execution.
That agility thing, I find that really compelling. It doesn't just sound like, going faster for the sake of it. What Varshney seems to suggest is this dynamism, this focus on speed, has actually opened up greater opportunities for engineers to make an impact. It's like the feedback loops are shorter, engineers see the results of their work much quicker. But what does that actually look like day to day? I mean, does it just make things more exciting, or does it pile on new pressures too?
That's a great question. It really gets to the heart of it. This dynamism, it shows up in things like continuous deployment pipelines. Code going live multiple times a day, not once a month.
Wow.
It means A/B testing isn't some big quarterly review anymore. It's constant, real-time experimentation, driving daily choices. So yes, definitely more opportunities for impact. Engineers are closer to the user. They can iterate based on what's happening now. But yeah, of course, that speed brings pressure. Constant adaptation, needing systems that are inherently robust, observable. It's maybe less about perfect planning way in advance and more about building intelligent, adaptable systems that can evolve fast.
Yeah, that makes a lot of sense. A trade-off, yeah, but it sounds like a net positive for actually getting innovative stuff done.
Yeah.
And this leads us right into what Varshney calls the most significant change he's seen, which is, no surprise maybe, the rise of generative AI. Just meteoric. This is where things really shift gears, right? Think about it. Generative AI, the kind that creates text, images, code. In 2017, it was pretty much a niche discipline. And now, just a few years later, it's central to nearly every product and workflow.
Right.
Everywhere. It's not just some add-on feature. It's like woven into the very fabric of how things are built and operate. But what does that do to the actual job of a software engineer, day to day?
Well, connecting this to the bigger picture, this incredibly fast shift means software engineers, they're no longer just building applications in that old sense, where they explicitly code every single rule, every function. Their role has massively expanded. Now they're expected to design intelligent systems that power those applications. It's not enough for an app to just work. It needs to learn, adapt, interact intelligently. The engineering challenge has genuinely shifted from coding the solution to maybe sculpting and guiding the intelligence.
Sculpting and guiding, I like that.
Yeah, and this change, as you can imagine, it's fueled this huge demand for expertise in machine learning. And looking ahead, even newer fields like Agentic AI.
Agentic AI. Okay, what does that really mean?
So, agentic AI, we're talking about building systems that can act independently. They can take initiative, achieve complex goals, multi-step goals in environments that are constantly changing. Think less like a tool you directly command and more like a really sophisticated assistant, one that can plan, execute, even course correct tasks all on its own. It's like designing an orchestrator instead of just a simple hammer. And that fundamentally changes the whole mindset you need for problem solving.
Okay, that distinction, coding solutions versus sculpting intelligent agents. That's a massive insight. It implies a totally different skill set, doesn't it?
Yeah.
It's less about knowing the perfect syntax for every problem, maybe,
Yeah.
and more about understanding how to prompt, how to fine-tune, how to manage these, well, intelligent systems. So what about engineers who are, let's say, 10, 15 years into their careers? Their training was probably in that more traditional explicit coding world. How do they adapt?
Yeah, that's a critical point. Adaptation is just, it's the name of the game now. It means continuous learning. And not just learning new coding frameworks, but whole new ways of thinking.
Yeah.
More experienced engineers might need to shift from that very deterministic, rule-based approach to
Uh-huh.
something more probabilistic, more outcome-focused. They're learning to sort of communicate with models, understand how they might fail, how to effectively prompt engineer or architect systems where parts might not always behave predictably. It's a fascinating challenge for sure, but also a huge opportunity for those who are willing to lean into it.
Right. Okay, now let's get really practical. Let's talk about the direct impact on Varshney's own work,
Hmm.
day to day. Because this is where it really hits home, right? He shares this remarkable transformation. Tasks that used to take days, can now be accomplished within hours, thanks to AI.
Yeah.
That's not just like a small improvement. That's a massive leap in productivity. It
Hmm.
totally changes the pace of work.
It's incredible.
Yeah. And he lists specific ways AI helps him out. It paints a really clear picture. Imagine AI suggesting potential bug fixes automatically,
Yeah.
or generating different versions for A/B tests, or even fine-tuning model parameters. He uses AI to debug, experiment, and optimize with unprecedented speed. It basically means the tedious, time-sucking parts of engineering are getting automated super fast. But I wonder, does a shift that fast, days to hours, does it mean engineers are just managing more stuff now rather than maybe digging deeper into fewer, really complex problems? Is there a risk of becoming, I don't know, more superficial?
That's a really thoughtful question, and it touches on how expertise itself is evolving. So yes, some routine tasks get sped up dramatically, but the engineer's role, it actually gets elevated. They're not necessarily juggling more individual tasks, but they're taking on a higher level, more strategic role. Instead of grinding through every single possibility manually, they become the orchestrators of these AI-driven processes.
Okay, orchestrators again.
Exactly. They dive deeper into the design of the intelligent system, the overall architecture of the solution, and importantly, the interpretation of what the AI spits out. Less time on the manual execution details. It's like shifting from being a craftsman meticulously using a hammer to being the architect designing the whole construction project.
Got it.
And this brings us to what feels like Varshney's most crucial quote. It really sums up everything we've been talking about. He says, the expectation is clear. It's not enough to build something functional. It has to be smart. That's not a wish, not a nice to have. It's the new standard, the benchmark. Functionality alone, table stakes. Intelligence is the real differentiator now, which means the bar for innovation is just being raised significantly. We've moved beyond does it work to how intelligently does it perform.
And you can just immediately see how that ripples out, right? We focused on tech today, obviously. But this demand for smart solutions, it's inevitably going to spill over into absolutely every sector. Think healthcare diagnostics, not just accurate, but proactively spotting complex patterns doctors might miss. Or financial systems, not just processing trades, but intelligently predicting market shifts.
Mm.
Even manufacturing a machine doesn't just assemble parts. It needs to intelligently optimize its own process, predict when it needs maintenance. It totally redefines what value even looks like in a product or a service.
Absolutely. Or think about something like urban planning or logistics. It's not just about finding the quickest route anymore. It's about a system that intelligently anticipates traffic jams, adjusts dynamically for unexpected events, optimizes how resources are allocated, all in real time. This smart expectation, it fundamentally changes how we even approach problem solving everywhere. It requires a deep understanding, not just of data, but the context, the desired outcomes for these intelligent agents to actually work effectively.
Okay, so as we wrap up this deep dive, let's just pull together the key things Varshney has shown us. First, the tech world today. Incredibly dynamic, relentlessly results-driven. It's all about rapid execution, direct impact. Second, AI. Not optional. It's shot up to become a core engineering skill, central to pretty much everything now. And third, the efficiency boost from AI is just dramatic, days shrinking to hours, which leads to this entirely new expectation. Systems have to be more than functional. They absolutely have to be smart.
Yeah, Varshney's perspective really highlights this huge shift in mindset that's needed, and not just for tech people, but really professionals across all fields. It's not enough anymore to just master your specific domain knowledge. It's about embracing intelligence as just an inherent part of a successful solution. To really thrive in this AI-powered world, it's going to demand constant learning, serious adaptability, and a proactive approach to weaving these intelligent capabilities into everything we do, viewing AI almost as a collaborator in innovation.
Exactly, a collaborator. So what does this all mean for you listening right now? As AI keeps accelerating innovation, redefining what's possible, changing that engineer's role from coder to orchestrator, how will this rising demand for smart solutions in engineering? Yes, but really everywhere, how will that shape the skills you choose to develop next? That's definitely something to think about as this landscape keeps transforming at, well, breakneck speed.